Hello, welcome. This is a lesson on how to graph quadratic equations when they're in factored form. This is yet another way to graph quadratics. Um, the sometimes called the intercept form of a quadratic, and it's in its factored form. So, an example, um, the intercept form of f of x equals x squared minus 10x plus 21. If you factor that, would be f of x equals x minus 7 times x minus 3. So these are some general rules for graphing quadratics when they're in the form of f of x equals a times x minus p times x minus q. You'll recall that the standard form was y or f of x equals ax squared plus bx plus c. Now, if you had a standard form equation like that and you factored it, the value of a would be the same. So the first step is factor if needed. Let's just say if not already factored, factor it. That's what it means by if needed. If it's not already factored, you need to factor it in order to use this form. Number 2, identify the x-intercepts and plot them. You're going to solve each x value, solve for the x value of each factor. The x-intercepts for f of x equals a times x minus p times x minus q in general forms are p comma 0 and q comma 0. The opposite of the sign that you have there. But we'll see that in an example, and you can always just solve for the little equations formed by setting them equal to 0. Number 3, find the vertex and axis of symmetry. You find the axis, the vertex, the x coordinate of the vertex is p plus q over 2. You take the two x values of your x-intercepts, add them together, divide by 2, you're finding the average. Here, think about it. It says it's located halfway between the zeros. All right. Then you plug in that x-coordinate of the vertex to find the y-coordinate, and you plot that point. That's the vertex. And the axis of symmetry is x equal to that point that's halfway between p and q, or p plus q divided by 2. Determine the direction of the graph. If a is greater than 0 or it's positive, then it faces up. And if a is less than 0 or it's negative, then it faces down. And then finally, number 5, sketch the curve by graphing the x-intercepts and the vertex. All right, let's say in this example, we're going to graph f of x equals x minus 7 times x minus 3. So we just note that it is already in factored form, so we don't need to factor it. Number 2, identify the x-intercepts and plot them. The x-intercepts are 7, 0, and 3, 0. Just real quick, let's look at how we get those. If I take x minus 7 and I set it equal to 0, and I add 7 to both sides, that cancels the 7 on the left, leaving x, and on the right gives us 7. So there's the 7 from 7, 0. And if we did the same thing, x minus 3 equals 0, adding 3 to both sides of the equation leaves x alone, and on the right gives us 0 plus 3, or 3. And so there's the 3 from 3, 0. So I go over here to my graph, and I plot 7, 0, and 3, 0. 7, 0 is right here, and 3, 0 is right here. And it says find the vertex and axis of symmetry. So we take p plus q divided by 2 equals 5. 7 plus 3 divided by 2 is the same as 10 divided by 2, which is the same as 5. And there's how we get that 5. And the negative 4 comes from putting this 5 back into the equation. So we say 5 minus 7 times 5 minus 3. And this is equal to our f of x, or equal to y. So 5 minus 7 is negative 2, and 5 minus 3 is positive 2, and negative 3 times positive 2 equals 4. And so the vertex is at the point 4, excuse me, it's not equal to 4. It's equal to negative 4. So it's a 5, negative 4, just like it says here. So I go over and I graph. The axis of symmetry is x equals 5, always equal to the x coordinate. So I go over to 5, down to negative 4, and I graph that point. And then I'm going to change color just to show my axis of symmetry, which is technically speaking not part of the graph, but it helps us to graph it. So we graph it as part of our process. And then we ask ourselves, does it face up or down? A equals 1. How do we know A equals 1? Well, A equals 1 because it's the number that comes before the sets of parentheses. Since I don't have a number, that's the same as having a 1 there. If there's a 1 in front of the x minus 7 and x minus 3. And since it's positive, it faces up. And then we sketch the curve. So we can sketch the curve, and it looks something like that. Now, just like in standard form, if we want to know another value, like let's say what happens when x equals 2, you could just do like we did to find the vertex and plug 2 into the equation. What happens when x equals 2 would say that's x minus 7 or 2 minus 7 times 2 minus 3. And 2 minus 7 would be negative 5, and 2 minus 3 would be negative 1. And a negative 5 times a negative 1 is a positive 5, and so the point 2, 5 is on our graph. And I go over here to 2, and I go up to 5, and I missed it there a little bit when I was sketching, but if that's on the graph, then over here this would be on the graph as well. So I made it a little bit too narrow, but we get the idea. You can always plug in other points to see a little bit better what your sketch would look like. Let's go look at the next ones. Negative 2 times x plus 3. So first of all, what are the x-intercepts? Well, what value of x makes x plus 3 equal to 0? And that would be negative 3, comma 0. And x minus 1, what value of x makes that equal to 0? And that would be positive 1, since it's already minus 1. 1, comma 0. So our x-intercepts are negative 3 and 1. Negative 3, comma 0 and 1, comma 0. Our vertex, we find the average, so we take negative 3 plus 1, divide by 2. And negative 3 plus 1 is negative 2, divide by 2 would be negative 1. And so the x-coordinate of our vertex is at negative 1. And then we plug that in to the original equation. So we've got negative 2 times negative 1 plus 3 times negative 1 minus 1. And that gives us negative 2 times 2 times negative 2. We've got 2 negatives, so it's going to be positive. And 2 times 2 times 2 is 8. And so our vertex is at negative 1, comma 8. And I go up to negative 1 and go up to 8. And I plot a point, and then the axis of symmetry is always going to be x equal to the negative, or to the x equal to the x coordinate of the vertex. So it's x equals negative 1. And at this point, you can sketch the graph. It's to go down, it's downward facing. And it'll look something like that. And again, you can find some other points to find a better idea of what the sketch looks like if you want to, or if your teacher asks you to. So x squared minus 2x minus 8, this is not factored. And so to factor it, I check for GCF, which there is not a GCF greater than 1. So I skip that step and I say, well, AC is negative 8 and B is negative 2. And so I'm looking for values that multiply, two numbers that multiply to negative 8 and that add to negative 2 with a little work that I can say it's 2 times 4 with the negative being on the 4. 2 times negative 4 is negative 8, and 2 plus negative 4 is negative 2. So those are my numbers. And then if I put it in the box, I get x squared minus 8 plus 2x and minus 4x, and then factor out the GCF of each row and each column. I get x, my factored form, f of x. I'm going to switch that f of x out just for y. It's the same thing, is equal to x plus 2 times x minus 8. Not minus 8, sorry, x minus 4 from our factors that we found here. And the x-intercepts then are the opposite of what we see in the numbers there. So that's not plus 2, but minus 2, comma 0. And over here, since it's minus 4, it's plus 4, comma 0. And the vertex, I average, I take negative 2 plus 4 divided by 2. And negative 2 plus 4 is 2. 2 divided by 2 is 1. So the x-coordinate is 1, which means our axis of symmetry is x equals 1. And then I plug it back in to find y. Y equals 1 plus 2 times 1 minus 4. 1 plus 2 is 3, and 1 minus 4 is negative 3. And so the y-coordinate is 3 times negative 3, or negative 9. And so then I go to my graph here, and I graph 1 comma negative 9. Oh, I skipped a step where I graph the x-intercept. Let's do that now. Negative 2 zeros right here, and 4 0 is right over here, and the vertex is at 1 comma negative 9 down here, and my axis of symmetry goes right down the center of those two. And also, you can use this to kind of help check. There's 3 units between this point and the axis of symmetry, and 3 units on the other side is the other point. So they have to be equidistant. So always use that to check to see how you're doing. And then I know this opens up because A right here or right here is the same number, which is 1. When there's no number there, we understand it to be 1. It opens up because it's positive. So that goes up, looks something like that. This goes up something like that. I missed that a little bit. Let's try it again. And my graph looks something like that. It's a little bit messy, but you get the idea. Let's look at C. Again, we need to factor this. So AC, there's no GCF. I want to make sure we check that. There's no GCF. So AC is negative 3, and B is negative 2. And if I take 1 times 3, that gives me 3. If I put the negative on the 3, 1 times negative 3 is negative 3. 1 plus negative 3 is negative 2. And if I then put it in the box, I got x squared minus 3, and then plus 1x and minus 3x. And then I factor out the GCF for each row and each column. I get x plus 1 along the top and x minus 3 along the bottom. So factored form, y equals x plus 1 times x minus 3. And the x-intercepts then are negative 1, comma 0, the opposite of that one, and 3, comma 0 is the opposite of the other factor. So we go down, and I put negative 1, comma 0, and 3, comma 0, and then I'm going to average those two by taking a negative 1 plus 3 divided by 2. And that negative 1 plus 3 is 2. 2 divided by 2 is 1. Which, once again, our vertex then means the x-coordinate is 1, and the axis of symmetry is x equals 1. And then I go back and I plug this into my equation. And you could plug it into the original equation or the one that's factored. I like the one that's factored a little bit better. So it would say y then is equal to 1 plus 1 times 1 minus 3. And 1 plus 1 is 2. And 1 minus 3 is negative 2. So 2 times negative 2 is negative 4, which means that the y-coordinate is negative 4 of my vertex. I then can go down and graph that 1, negative 4, and graph my axis of symmetry. And then I can sketch my graph. And it looks something like that. And then D. So for D, it's already factored, so that's nice. So we can jump right to our x-intercepts, which are negative 1, comma 0. That's negative 1 would go in here for x, and that's what would make this 0. And here it would be negative 5, comma 0. So those are the x-intercepts, and I can graph those, negative 1 and negative 5. Negative 5, negative 1. And then I would average them. Negative 1 plus negative 5 divided by 2. That's negative 6 divided by 2, which is negative 3. And so my vertex is negative 3 in its x-coordinate, and the axis of symmetry would be x equals negative 3. And the y-coordinate, y equals negative 1/2 times negative 3 plus 1 times negative 3 plus 5. And that gives me negative 1/2 times negative 2 times positive 2. And I have a negative times a negative, so that's positive. 2 times 2 is 4, and half of 4 is 2. And so the y coordinate of our vertex is 2. And so I go here to negative 3, 2, and I show my point there. And my axis of symmetry, x equals -3, is that vertical line that goes through -3 in x. And then I can sketch what my graph looks like. And it would look something like that. Practice, practice. Reach out for help if you need it. You're going to do great.